Now that you have learned how to find the solution to a system graphically, it's time to discuss how to solve a system algebraically. So in this section, we're going to discuss the first method for solving systems algebraically, which is the elimination method, or also known as the addition method. So the elimination method is defined as if we have a system of two equations, we can manipulate the equations within the system in a way that cancels out one of the variables when we combine their like terms. This way, we are presented with only one variable, x or y, and we can solve the equation as we would solve a linear equation, as we've seen in Unit 2 of this course. So let's start to dive into some examples to see more about what this looks like. So for example 1, we are told to find the solutions to the systems below using the elimination/addition method. So for example number 1, we are presented with the system with an equation negative x plus y equals 0, and a second equation 2x plus 3y equals 0. Now, looking at this first equation here, I notice that we have a negative x here and a positive x, and both our y's are positive. So what I'm going to do, so this elimination method, right, this idea is that you multiply one of these equations by a number, the whole equation by a certain number, so that way the variables cancel out when we add them together and combine like terms. So looking at this top equation here, since we have a negative x and the bottom equation is a positive x, I'm going to multiply this top equation by some value. And specifically, I'm going to multiply it by 2, because 2 times negative x is negative 2x, so negative 2x plus 2x, that cancels out. So that's why I'm doing it. But let's see. Let's distribute this 2 to this whole equation. So every single term within the equation. So we get negative x times 2, or negative 2x. And then 2 times y, well, that's just 2y, so we're going to add 2y. And 2 times 0, well, that's still 0. And then we're going to bring down the second equation just as it is because we didn't multiply anything to it. So I'm going to carry down that 2x plus 3y equals 0. Now when I combine our like terms, well, negative 2x and positive 2x, they cancel. So, and then here we have our y terms. So I'm going to do 2 plus 3, which is 5, and I'm going to bring along that y. 0 plus 0, well, that's just 0. Now, I'm going to solve for y. And to solve for y, we just simply divide by 5 on both sides. And we get y equals 0 divided by 5, well, that's just 0. So now, well, what do we do? Because remember, when you're solving a system, you're looking for a point, x, y. So this is not the solution to the system. This is our y part. This is our y coordinate of the system. So we have the point x comma y. So what this means is we still need to figure out what our x part of the coordinate is, but we found our y part, which is 0. So to figure out the x part, here's what we can do. We can take what we got for our y value, which is 0, and we can bring this guy over here and plug it in to one of the linear equations we have up here. So I'm going to plug it into the second equation. So we're going to get 2x plus 3 times, excuse me, plus 3 times y, and y is 0. So we're going to get 3 times 0 equals 0. So we're just going to carry along that 2x, and 3 times 0 is just 0. So I'm going to take away that addition sign. And then we're going to carry down equals 0. And now to solve for x, I'm going to divide by 2 on both sides. And we get x equals 0. Well, we got x equals 0 and y equals 0. So that's perfect. That's exactly what we need. So our solution to the system of equations is actually 0, 0, the origin. Alrighty. So looking at example 2, we have the system x plus 3y equals 2 and 2x plus 3y equals 4. So looking at our x and y terms, our y terms are the same, 3y and 3y. So naturally, what I want to do is multiply this entire top equation by -1. So we end up getting -3y for the top equation, and our y variables cancel out when we combine like terms. So to distribute, I'm going to distribute this -1 to all the terms in the top equation. So we get -x minus 3y equals -2. And then the second equation, I'm just going to bring it down just like it is, because we didn't do anything to the top equation, or the bottom equation. And now, when I combine like terms, we have -x and 2x, so -x plus 2x, then that ends up becoming just 1x, or just x. And then -3y plus 3y, well, those cancel. And then we're going to say x, and then equals -2 plus 4 is just +2. Well, we just have x equals 2, so that's our answer. That's what x equals. So that was easy. And now we're just gonna take whatever x equals and plug it in to one of the equations. This time I'll plug it into the top equation because I did the bottom equation in the first example, but you can do either or equation in any systems of equations to figure out the other missing variable. So I'm going to plug in x for the top equation. And the top equation is x plus 3y equals 2. So we're going to have x, which is 2, plus 3y equals 2. Now, to solve for y, I'm going to subtract 2 on both sides. So these 2's cancel, and you get 3y equals 2 minus 2, well, that's 0. And then to solve for y, I'm going to divide by 3 on both sides. And we get y equals 0. And our final answer is 2, because that's our x-coordinate, or the x part of our coordinate. So we get 2, and y is 0, so 2, 0. And that's your solution to the systems of equation. Alrighty. So, for example, number 3, we are given -5x plus 3y equals 3. And then for a second equation, we are given 4x minus 15y equals 6. So this time, we could either cancel out our x terms or our y terms. Either or will be about the same difficulty. But let's cancel out, actually, never mind. Canceling out our y terms in this case will be the easiest, because if I were to multiply this top equation by 5, you'd get 15y, and 15 minus 15, or 15y minus 15y cancels. So that's what I would do. So let's do that. We're going to multiply this top equation by 5. So then what we get is -5. -5x times 5 is -25x. And then 5 times 3y is 15y. And then 5 times 3, well, that's also 15. And then looking at the second equation, we're just going to carry it down like it is. So -4x minus 15y equals 6. And now, -25 not minus 4x. It's just positive 4x, my apologies. So negative 25x plus 4x equals negative 21x. And then the y variables cancel out. And we're going to set that equal to 15 plus 6, which is 21. And then to solve for x, I'm going to divide by negative 21 on both sides. And we get x equals negative 1. Now, I encourage you to pause the video and try to find the y part of the coordinate. And assuming you have done that, let's go through this together. So to find the y part of the coordinate, I'm going to first start by plugging in x to either one of the equations. This time I'm going to plug it into the bottom equation. So we get 4 times x, which is negative 1. And then we're going to subtract 15y and set it equal to 6. Now, to solve for y, well, first I'm going to start by simplifying 4 times negative 1, which is negative 4. So we get negative 4 minus 15y equals 6. And now to solve for y, let's add 4 on both sides. We get negative 15y equals 6 plus 4, which is 10. And now, to solve for y, I'm going to divide negative 15 on both sides. And I get y equals 10 over negative 15. I can actually simplify that. If I divide by 5 to both the numerator and denominator, I get 10 divided by 5, which is 2. And I'm going to put that over negative 15 divided by 5 is negative 3. So we get y equals 2/3. So the solution to this system of equations is negative 1, comma, negative 2/3. Alrighty. So for example number 4, I encourage you to pause the video and try to solve this system completely on your own. And assuming you have tried this on your own, let's go through this together. So we have negative x plus 2y equals 5, and 3x minus 4y equals 23. So, looking at this, we have a negative x and a positive x term, positive y term, and a negative y term. So, we could either cancel out our x variables or cancel out our y variables. In the last example, we cancel out our y variables. So I'm just going to mix it up a little bit and cancel out our x variables. And to do that, I'm going to multiply the whole top equation by 3. So when we distribute in this 3, we get negative 3x plus 2 times 3 is 6. Then we carry along that y. And 3 times 5 is 15. Now let's carry along that bottom equation. 3x minus 4y equals negative 23. And now our x terms cancel. And we have 6y minus 4y, which is 2y. And then 15 minus 23 is negative 8. And then now we have to divide both sides by 2 to solve for y. And we get y equals negative 4. And now let's plug in y to find the value of x. So I'm going to plug in y to the bottom equation. So we're going to get 3x minus 4y. So 3x minus 4, and y is negative 4. So I'm going to multiply this by negative 4. We're going to set that equal to negative 23. Now to solve for x, I'm going to start off by simplifying this. So we have 4 times negative 4, which is negative 16. So you'd get 3x minus negative 16. And recall, whenever we subtract a negative, our sign changes to addition. So we're going to get 3x plus 16 equals negative 23. And then to solve for x, I'm going to subtract 16 on both sides. We get 3x equals 23 minus 16 is going to be negative 39. And then divide by 3 on both sides. And we get x equals negative 13. So our coordinate point is going to be, I'll write it right here. Our coordinate point is going to be negative 13, comma, negative 4. So for our last example, we have the system negative 4x plus 3y equals negative 7 and y equals 5x minus 17. So this one looks a little bit different than what we've seen. And that's because the second equation here is set equal to y. But to make this look like all the other systems we've seen, what I'm going to do, or what we are going to do, is take the second equation here. I'm going to bring that up here. Y equals 5x minus 17. And I'm just going to simply subtract 5x on both sides. So what we get is y minus 5x equals negative 17. So this here is this equation, but in standard form. This is the slope-intercept form, y equals mx plus b. This is the standard form. So what I'm going to do now is I'm going to rewrite this system. I'm going to simply just write the first equation like it is, negative 4x plus 3y equals negative 7. And then I'm going to now take the standard form and bring it down here. So we're going to get, I'm going to bring down this y. We have a positive y here, so I'm going to bring that positive y there. So our terms line up with each other, and I'm going to bring down this negative 5x here. And I'm going to set that equal to negative 17. And now, using elimination, we have negative 4x plus 3y. So looking at this, right, we have two negative x terms and two positive y terms. But because this y is just on its own, since we just have one y, it'll be easier to multiply this bottom equation by negative 3, so our y terms cancel out. And when we do that, we get, so I'm going to carry down this first equation just as it is. So we have negative 4x plus 3y equals negative 7. And this bottom equation, I'm going to multiply negative 3 to each of the terms. So we have negative 3 times negative 5x, which that becomes 15x. And then there's supposed to be an addition sign there. And then we have positive y times negative 3. So that becomes negative 3y equals 17 times 3 is 51. So now, when we combine our like terms, we get negative 4x plus 15x. So that becomes 11x. And our y terms cancel, and we get negative 7. This should be 7. And negative 7 plus 51, which that's 44. So now when we divide by 11 on both sides, we get x equals 4. And now we're going to plug in 4. We're going to plug in 4 to this second equation here. So this is the thing. So because this equation is the same thing as this one, just written in different forms, I can plug in x to this form of the equation. Because these two equations, they're the same thing. They're the same equation. So I can plug in x to this equation here. So we're going to get y. Oops. We're going to get y equals 5 times x, which is 4, minus 17. So y equals 5 times 4 is 20, minus 17, y equals 3. So our solution to this system is 4, 3. And that's your answer.